Yeah. I think you can go.
I thought it was what they do. It's not.
Where would people prefer that I put the microphone? I could have the microphone right there, or I could leave it on this table. That way the speaker might be away from the person who's making this go. I don't know if you're normally going to make your own slides go, or if you have your lab mate make your slides go for you. Who's advancing the slides typically in your group? Are you advancing as you go, or?
I know I'm a walker.
You're a walker? Okay, so maybe the table is better, so we'll just be mindful of where the microphone is. Okay.
Been like hiding myself all day most of the show. I'm gonna like slowly sinking down.
Okay, how you doing?
I feel a little This is the worst weekend. Yeah, a lot going on. Sometimes there's just a lot all at once. Oh my god. Can we go crawl in a hole? You know, like if they force it out, I feel like occasionally it's just like everything just insane. I'm sorry. I'd rather just fuck it. Let's just go.
That makes sense. Like, it's hard, you have to like detangle your hair from the
whatever. Almost.
Okay, we've got 1:30. Why don't we get started? Good afternoon, S&P Research. All right. Looking forward to your presentations today. What we'll do is we'll follow the pattern of you giving about a 12-minute talk. Okay, we'll try to time you and see how you're doing on timing. And then we'll have several minutes for questions and feedback. Please make sure that you give feedback to the group that's up here presenting. This will be their last chance to get feedback. I have placed the microphone right here, so we'll ask that the speaker try to get yourself centered right about here so that we can pick this up as effectively as possible. And please speak loudly. Maybe I'll stay toward the back of the room and just keep your eye on me and try to project to the back of the room so that everybody can hear and it comes across really loudly on our microphone. Okay? I haven't tried to record these before. We'll see how we do. All right, why don't we take the groups in their order. We'll do group 1, 2, 3, and 4 in that sequence. Okay? So we'll invite group 1 to come on up now. And they can line up their PowerPoint presentation. We'll start the timer, and away we will go. Okay, so let's have group 1 come on up, please. When you're beginning your talk, if you could please introduce yourselves. Okay? And again, really loudly if you would.
Okay. Hello, my name is Sabella Packen.
I'm Sarah Datsko. And I'm Meg Schmetza.
We are here to present our study on the relationship between the Simon effect and hand crossing. So what is the Simon effect? Well, the Simon effect refers to the psychological phenomenon that spatial correspondence, what we term congruency, between a stimulus and the physical response to it determines the speed and accuracy with which an observer reacts to the stimulus. So when people observe a stimulus in their right visual field, they respond more quickly and more accurately with their right hand than with their left hand. Specifically, a study found that there is a the Simon effect causes a 2-second delay in reaction. So we asked the question, perhaps the delay observed in the Simon effect was affected by hand placement, specifically by the crossing of one's hands to respond to stimuli. You see, past research has found significant correlational and causal relationships between hands and spatial processing in visual perception. In the research that we found on hands as visual cues, we learned that the placement of hands near an object has been found to improve or significantly improve an observer's spatial processing of that object. Based on these findings, a study conducted by Liepelt in 2014 examined the effect of hands as visual cues on the Simon effect. What the study found was that rather than decrease the Simon effect as hypothesized, the placement of hands near the object observers responding to increased the effect of the Simon effect on observers' reaction to the object. We then looked at research on hand crossing. As the researchers Yamamoto and Kitazawa noted in their study on arm crossing, the brain factors in the spatial locations of the hands determine the location of the stimulus in space. When the spatial placement of the hands is made atypical by crossing one's arms, observers' ability to correctly and quickly identify determine the location of a stimulus deteriorates, or significantly deteriorates. Similarly, research on embodied cognition and the Simon effect found that observers' motor and cognitive reaction to a stimulus was inhibited when the location of the stimulus required them to move in the opposite direction of the response. So, based on these findings, we hypothesized that hand crossing and the Simon effect were significantly related. Specifically, we hypothesized that the Simon effect will be greater for those who cross their hands when responding to stimuli than those who did not cross their hands.
So now to go into a little bit about the method. First, we had an IRB form that was approved by the Denison University Human and Animal Subjects Research Committee. When our participants came in, everybody signed an informed consent. We had 33 participants total. They were all enrolled in the intro psych class here. We considered gender irrelevant to our study, and all participants received 2 credits on SONA for completion of our study. We had 15 participants in the experimental or hands crossed group, and then 18 participants in the control or hands normally placed on the keyboard group. And once they were done, they were thanked and given a debriefing form to take with them. So what they did is they completed the Simon effect task on CogLab, and like we said, we had 2 conditions. Control was hands uncrossed, and then hands crossed was our experimental condition. Data for these conditions were collected on 2 different days. Response times and trial congruency were recorded. The trial congruency and response times are all recorded automatically by CogLab, and we just collected that information. So they were asked to stare at a fixation dot on the screen, and they sat about 65 centimeters away from their eye to the screen. And then a red or a green square, all the squares were 1 centimeter by 1 centimeter, appeared 12 centimeters either to the right or the left of the fixation dot. And they were asked to press the V key if the square was green and the M key if the square was red. So this is kind of a visualization of what the Simon effect is. On CogLab, we just took screenshots of the task. And for the control group, that's a picture of the control group. They had to hit the V key with their left hand or the MQ with their right hand if they saw a green or a red stimulus. And then according to the Simon effect, their reaction time should be faster and they should be more accurate when the green square appeared on the left side of the screen for the control group. And then when it appeared on the right side of the screen, they were expected to have a slower reaction time because it wasn't congruent with the entire left side of the body or the entire right side for the red square. So for our variables and design, we had a 2x2 mixed design. Our independent variables were congruency, so congruent or incongruent, that was within subjects, and that was manipulated automatically by CogLab. So congruent, just everything being on the left side of the body, or incongruent, the stimulus appearing on the right side, and they had to report it with their left hand. And then hand position was our other independent variable, so either crossed or not crossed, and that was between subjects. Our dependent variable was response time, and that was recorded in milliseconds. Then we used an ANOVA run in SPSS, and based on the design of our study, we could assume sphericity and didn't have to run any post-hoc tests. To go over the results, we only found one significant main effect, and that was congruency, which is what we expected because that's what the Simon effect says, is that you're going to have faster reaction times when the trials are congruent. So that effect was expected. We did not find a main effect of hand position, and we also did not find a significant interaction between hand position and congruency, which was what we hoped for. And this is also the graph that we included in our report. For the control group, on the congruent trials, they had a mean reaction time of about 562 milliseconds, and for the crossed hands group, or experimental condition, theirs was about 615 milliseconds. And then for the incongruent trials, for the control group, the mean reaction time was about 594 milliseconds, and for the crossed hands group, it was about 663 milliseconds.
Okay, so just to reiterate, we had originally hypothesized that reaction times would be longer for those who crossed their hands on the Simon effect test than those who didn't cross their hands on both the congruent and incongruent stimuli, and that that reaction times would be longer for both groups when presented incongruent stimuli, that's a presence of a Simon effect. So we found a significant main effect of the congruency manipulation on reaction time, which did support the presence of a Simon effect. And the results also displayed a non-significant main effect for the hand position manipulation on reaction time and a non-significant interaction effect between the congruency manipulation and the hand position. So overall, our findings just suggest that hand crossing did not significantly affect performance on the Simon effect task, but there was the presence of a Simon effect. So although we didn't find a significant effect for the hand position manipulation on reaction time, the differences in the mean reaction times, which was showed by our graph, although they were insignificant, there was a slight difference, and this slight difference could have indicated that participants who crossed their hands did take longer to respond, and than those who the participants who didn't cross their hands took longer to respond than those who did, and that so if this was the case, then our study would support the previous idea that discrimination of temporal order gets worse when our hands are crossed versus uncrossed, and previous research that just said the more that hand position kind of strays away from a usual position, the worse that you do. So the further apart your arms are, or the closer they are, and then crossing the forearms. So as you get away from it, you get worse and longer response times. We also thought that task relevance could have played an effect, and although insignificant results again, the slight difference in mean reaction times could also support that task relevance did play a role in their reaction time. A prior study kind of proposed that when you're presented with congruent stimuli, there is almost an automatic process where you have a direct route to that kind of gets you the correct response. But when you're presented a incompatible or incongruent stimuli, that direct route still kind of fires, but then you get the incorrect response. So what they were saying that the task kind of plays an influence where you have to take the task into account to spatially remap the stimulus to get to the correct response when you're presented incongruent stimuli, which this having to spatially remap causes longer reaction times. So some limitations to our study is that we had high internal validity, low external validity. We did measure what we wanted to measure, but due to the crossing of the hands, it's pretty unusual for people to perform daily tasks with their hands crossed. Participants' response time in the crossed hands condition was kind of hindered by the unusualness of it. They weren't really used to crossing their hands, and they didn't get any practice time before doing it, so that could have affected their performance. Conflicting instructions on the experimental condition. On the COD lab, there was already a box of instructions for the control group, and the experimental group had different instructions that we gave them verbally, but those conflicted with the instructions presented them, so that could have caused confusion on the task. And pre-existing visual limitations, such as astigmatism and color blindness, could kind of affect focus of one's attention on the stimuli, or just being able to even perceive the stimuli. And then the presence of participants in the room could have also been distracting and affected response time. So due to this, future research we thought should move away from the constricting control of the assignment effect. An example is just measuring participants' response time to alternating stimuli and photographs. Together with past research, our study suggests that the assignment effect plays a role in people's daily functions. So it may be advantageous to study the physiological mechanisms related to the assignment effect, investigate the correlational and causal relationships, split brain participants, and visual processes. Perhaps researchers could also consider whether the assignment effect was caused by problems in communication between different brain regions, conflict arising due to maybe the differences between the right and left hemispheres of the cerebral cortex, thalamus, and maybe like failure and may arise at the octave chiasm and so forth. So overall, future research is imperative to not only further our findings, but to also investigate information and interactions pertaining to the assignment effect, spatial distortion, temporal order judgment, and the broader concept of embodied cognition. So, thank you very much for listening to us.
1:44, we started at 1:34, it was 12 minutes. So that was like right on. And the times I had roughly were approximately 3, 3, and 4 or 5 or something like that for each of these sessions, which is really nicely managed. Can we have some questions or comments or feedback from the other students, please?
Yeah.
Well, I think you guys did a good job, and you obviously had a lot of information to cover and everything. I just think it might be nice if you picked out some of the most important details of your findings and things, and maybe leaving out like the particulars of it, because for me at least I got a little lost in your presentation. That might have just been because of like time constraints and stuff, but it might be nice just to like focus on the really important stuff instead of like the gory details of it.
I think that'll also help with like if you can take out the details and focus on those important things, like the speaking really fast. Like there was times where like I'd be like, okay, what did she just say? And I try to process it, and then like it would be like way over here, and I was like, oh, I missed the part. So just like slowing it down a little bit more.
I really liked how you guys presented like at the beginning when you were just like what is the assignment effect? Like you just presented it in a really simple way, even though it got much more complicated, but like you just kind of like set the baseline for like here's what this is, and then later on you're like here's our questions, here's our hypothesis. I just thought it was formatted really nicely.
Okay, maybe you'll have some other ideas. I have just a couple of thoughts. First, very, very nice speaking, really, really nice. Just some things that we might want to clarify. I think early on we might have said that some studies had indicated that the assignment effect might cause something like a 2-second delay or something along those. That seems like a really big effect, and maybe that's what it is. Is it really 2 seconds, or is it on the order of milliseconds? Maybe
It was milliseconds, but that computed roughly to 2 seconds. Like, I can't remember the exact number of milliseconds, but like they said that it computed roughly to that 2 seconds.
Okay, it seems like a really long, and maybe that's what it is. Maybe
I can relook at my notes to get the milliseconds if that would be more accurate.
Well, and it's 2 seconds really, and you don't have to say 2,000 milliseconds, but it just, I thought I'd question that figure only because that sounds like a really big effect size, but maybe it is that big. And if it's that big, then that's fine. So we'll double check that number, because that might be what it is. If that's what it is, that's great. If it is that big, you might make a point of it, but that's a really long amount of time. Normally, when you've seen some of your reaction times, right, they're on the order of hundreds of milliseconds, and then there's, well, can we count that?
Actually, yeah, no, I'm thinking about that.
Yeah, they're about like 600 probably average.
Okay, so they're averaging 600 milliseconds, right? And then if the idea is that the Simon effect, the effect is costing us 2 seconds, that would almost be 3 times the height of any one of these bars, right? Okay.
I don't know, that's what I found in the article. I'll recheck it though.
Okay.
I'll make sure I understood exactly what you're saying.
Just an idea, it could be that the Simon effect under certain conditions is that, but when we delve back to the intro, some of the opening slides beautifully laid out lovely methodology slides. If we go here, okay? So on the background, love that you've emphasized ideas rather than names of articles. That's very helpful. Could you please add parenthetically the names of the supporting articles here? I think probably in your reference section. But if you can, and you don't need to talk about them by name, but if you could just add those in there, that would be really great. Okay, then we moved along. All was really solid. There was a little bit of conversation about sphericity assumption, which is assumed because it is a 2x2, which is fun. I think I heard something about post hoc tests, and I just wanted to make sure that it was clear to the audience that post hoc tests are one phenomenon, sphericity is a different phenomenon, and so we wouldn't say something like because we can assume sphericity, we didn't have to do a post hoc test or something like that. So, and maybe I misheard, but I just wanted to make sure that if you talk about those two, that one is not causing the other. Yeah. Other things, at several points, each of you gestured very appropriately. It helps your audience when you gesture. And you have a really good reason to be gesturing, because you're always talking about hands crossed or hands uncrossed or hands far apart. That was one of you or more from one of you did that. That was really, really helpful. So help your audience with gestures. Something else for this group. That was very well done. The timing was terrific. We'll see how it comes out on video, but I had no trouble hearing you. And I don't, maybe you were just a little bit to one side of the microphone, so we'll ask future groups if they could center themselves a little bit more effectively on the microphone, but I think that worked really well. Okay, we're just about at 1:49, and we can't take more than 20 minutes entire for each of the groups because we have 80 minutes. Can we thank this group one more time? Group 1, great job. Thank you for your hard work on that. Why don't we let Group 2 transition into position and we'll get started when they're ready to go.
I'm sick today, so if you can't hear me, I'm really sorry. I'll try. Also, if I start coughing, please bear with me.
I saw you this weekend on stage, and I didn't hear any sickness.
That is amazing to me because I've been sick.
You know, the interesting phenomenon about that, there's a woman whose name is Connie Chung. She was a newscaster. I don't think she's still on the air. Maybe she is, maybe she's not.
I'm not sure.
But anyway, Connie Chung had terrible allergies. And as soon as she was on stage, so to speak, and the red light came on and they're on the air, in 20 years on the air, she never sneezed once. The red light goes off, and she starts sneezing. Huh. But sometimes when you're on stage or whatever it is.
Maybe I'll be great right now.
I'll let you two say when they're ready. Are you set? And then I'll keep my eye on the timer. Yeah, is it?
I think so.
Okay, please go ahead.
So welcome to The Wonder of Video Games and You. Alexa, Claudio, and I will be presenting our research on the effects of video games on visual search today. So visual search is a type of perceptual test that requires people's attention in actively scanning visual environments for a certain target among distractors. So this here is an example of what a visual search test might look like. In array 1, you see what a smaller set size might look like, a set size of 6, with 5 distractors and 1 target. Set sizes can also be very large, as seen here in array 2, with 48 distractors and still only 1 target among them. So previous research surrounding our topic of interest, the focus fell primarily on participants that have had previous experience with video games. And in their previous gaming experience, they've acquired a set of skills that might not necessarily be applicable to other people. They also played with great regularity that might be a bit above average. These studies and other studies as well seem to spend a little bit more time with the video game implementation with their participants, meaning that they could have had about hours of time with the video games, days, or several weeks. Other studies also looked into the question of whether or not are action-based video games necessary in finding significant improvements on the visual search in participants. And these action-based video games tend to be anything sort of like Call of Duty, Halo, things like that. In almost a direct answer to that, everyday games were used as material as well in other studies. Everyday games meaning particularly visual blitz, and that's something that we could all sort of find on smartphones or on computers, and these are more puzzle games or word search type things, not so much action-based. And additionally, in our research that we found, real scenes were used as the visual environments for the backdrop instead of like that white background that you saw for the other targets and things. These were used as pictures of parks or the school grounds or something like that.
Okay, so I'm going to talk about our objective. And one thing that our study contributed that no other study really focused on was the brief exposure to video games before the visual search. So we had our participants play the video game for like 10 minutes before giving them the visual search. And we wanted to see if it was potentially beneficial for the reaction time for the visual search. So we also separated the data into two parts, whether the target was present or not. And yeah. So we designed our current study in a 3x3 factorial design to where it was two independent variables that had 3 levels each. We had I Spy, Helicopter, 2 video games, and the control group, which had none. And our CogLab visual search test would be separated by set size, which was 4, 16, and 64. And we looked at the target if it was present or absent, as well as the reaction time. And we hypothesized that going from left to right, I Spy would have the lowest reaction time, followed by the helicopter, and finally control. And we had a similar hypothesis to the set size, which was when it was less like distractors in the information, it would be less reaction time, followed by 16 by 64. And we also predicted a significant interaction between group and set size. So the group would affect the size as well as the size affect the group. And we predicted a main effect for group and set size separately.
So to get into our materials and methods a little bit, participants a little bit. Our participants for this study were 55 introductory psychology students. Their age range varied from about 18 to 21. All of our participants signed up voluntarily through Denison's SONA system, and as compensation for their participation, we granted them 2 SONA credits each. So as Claudia was talking about earlier, these are some of the materials that we used in our study. They were all computer generated, obviously. The I Spy Seek and Find game seen on the picture on the top figure. This is one of 3 pictures that participants might have seen. In each of the scenes, however, they would see a realistic scene with realistic items that they needed to find in those scenes. Participants were able to go in and zoom in on each and every aspect of that picture, priming them for visual search. The helicopter game seen in the bottom figure here did not have any sort of visual search impact on it, but we decided it was important to use so that participants were not primed by simply looking at a computer screen anyway. So for this game, participants simply had to click or not click on the mouse in order to move the helicopter to avoid objects within the flight path. And finally, CogLab visual search test was also used. This is a good example of what a large set size might look like on the CogLab disk. On the black background, we have a bunch of blue squares, and those are all the distractors, and here the target is present, which would be this lime green circle right there.
So before the students came in, we had decided what group they're going to be in. So for example, one day we're going to do helicopter, the next day we're going to do I Spy. So when they came in, everything was set up, so they were doing helicopter, which says, well, someone here, a person right here, and have an informed consent. And once they were finished with that, we would collect them and they would just be prompted to the game. And they would play that for 10 minutes. So I Spy and helicopter for 10 minutes. And if there was a control group, they would simply, CogLab would just be set up to where they would start as soon as we gave them the instruction to. So yeah, they're just assigned for like the 3 groups, and just basically repeating what I said. And finally, once they took the visual search, it lasted from 5 to 10 minutes usually. And once they were done with that, we were giving them the brief form, and they were dismissed, and we were done collecting data.
Okay, so here are our results. This is when the target was present on the screen. As you can see, this is a graph indicating the reaction time in milliseconds for each group. These are the stats that we ran for that. When the target was present, we only found a main effect of set size, which we were expecting. That's the way that CogLab is set up, such that a smaller set size should result in lower reaction times. It's easier to determine whether or not the stimulus is present or absent when there are less distractors on the screen. We did not find a main effect of group or an interaction when the target was present. These are our results when the target was absent, so when the participant had to indicate that the target was not on the screen. And as you can see, we had, again, the expected main effect of set size, and here we did have a main effect of group and significant interaction. Post hoc t-tests revealed that that was due to significantly lower reaction times. I'll go back there. As you can see, in the helicopter group, in the I Spy group, but only when there were 64 distractors on the screen. And again, this is only when the target was absent. So, it's kind of interesting. So, our results revealed that a single 10-minute exposure to video game play immediately prior to a visual search task did not generally improve reaction times on that visual search task, but it did only when the target was absent, the set size was large, aka 64, and the participant had played the helicopter game, and not I Spy. Okay, so yeah, sort of exactly what I just said. Previous research sort of in line with that. 10 minutes of video game play can improve performance under very specific conditions. So contrary to what we hypothesized, those specific conditions did not include the I Spy group. So we hypothesized that the I Spy group would have the lowest reaction times, followed by the helicopter and then the control. We actually found that when there was a significant difference, the helicopter group had the lowest reaction times. There are a couple of potential reasons for that, which we'll get into on the next slide. But we had very good internal validity on this study. We had, through the use of computers in the CogLab disk, a lot of control over exactly what participants were exposed to. However, it's difficult to say how well this would generalize beyond tasks, specifically on a computer, specifically the visual search task. It's difficult to say whether any amount of video game play would help in a real-world search task, like looking for your keys on a cluttered desk. Thank you. So basically, it looks like occasional video game play on phones or other devices may provide some useful information. However, that's not necessarily when the game is related to visual search, like we were hypothesizing. So we recommend that future research look into whether this has to do with priming, whether it has to do with practicing video game play, or if something else is going on here. One of the reasons that we came up with as to why the helicopter group might have lower reaction times occasionally than the I Spy group was this idea of a sense of urgency. People in the helicopter group had to respond very, very quickly in order to keep their helicopter from hitting any of the obstacles. So perhaps, whereas people in the I Spy group were used to taking as much time as they needed to determine whether or not, or to find the objects that they were looking for in the screen. So perhaps practicing that sense of urgency, that responding very quickly, was useful in this case. It may also be the case that people in the helicopter group got used to taking in the entire scene, the entire picture that they were looking at once, whereas the I Spy group could freely zoom in on any portion of the screen, which they couldn't do in the visual search task. So perhaps that had to do with it. Like I said earlier, generalizability, how well this extends to real-world visual search phenomena, and whether single-session exposure to video games is helpful in tasks that don't have to do with visual search. And I believe that's the end. Thank you very much.
your first approximation, I had that as about 11 minutes long, so nicely timed. Right? That fits pretty well into the range, and if you wanted to go a little longer or add some more information, you could, but you wouldn't have to. That's close enough. Let's go to our students first to see who has comments or feedback that would be helpful. Sorry.
Yeah, I really liked the way you guys organized everything. I think it was a really good description of everything. You didn't talk too fast, so it's really easy to comprehend. One thing that it might be helpful to include is just if the participants were all tested at the same time and like how they were randomly assigned. Or not if they were all like on the same day. Thank you.
I agree with Sarah that I thought like it was really well laid out. I understood everything like very clearly. You guys made it a habit of like when we presented something that like you kind of explained it and not just like left it there for people to kind of like chew on. The one thing at the beginning, it was a little bit informal. There was one point where like I think you said the flow is like obviously about computer, like that kind of like put a weird taste in my mouth. I would kind of avoid that because I think it's a little too informal when like presenting, and it just kind of looks like obvious, like you know what I mean. But other than that, that's just like picky. But it's good.
Sorry, I just have one little tiny thing. On the picture that you guys took a screenshot of the black screen with the blue like squares, it might be helpful to like turn the lights down just temporarily because it's kind of hard to see the blue squares because it's like really bright with the lights. So
I can see that now.
if you could even just like just for this slide, just flash the lights off quickly. That would be helpful.
Thank you.
On the back.
Yeah.
And I realize that was probably a screen capture from
Cogla.
Cogla. Because you kind of stuck with what you had. You also stuck with how many photons that projector can go that far. So there used to be that point. And thanks for saying that. So can we go back that slide just for a moment? I want to do a quick poll on that slide. So when I saw the slide from here, I saw the green dot, and I knew there were blue dots, and when I go looking for them, I can kind of see them, especially for people in that. Is anybody else have trouble seeing those blue dots? Or they're kind of, I can tell you. Yeah, why don't we just try the Nicholson contrast manipulation. Hey, there we go.
Better.
Contrast really works.
Cool.
Right? But, okay, so that would be.
Does it work there, too?
So them off.
Can we put them up, because if we keep them all the way up.
For this slide.
Yeah, let's keep them all the way up for today's video. It works better because we actually are better photographed under brighter light for this video before we talk on Wednesday, and we'll take that down just before we take the lights down just for this one slide.
Okay.
One other note about this, well, one second to remember. As you are aging, the lenses in your eyes are gradually turning yellow. So probably my eyes are more yellow than your eyes, and your grandparents' lenses are maybe more yellow than your parents' lenses. So that's called a cataract. It's actually a yellow. And so what happens, very interestingly, is that yellow is relatively long waves. So longer waves like that green will tend to come through-ish, and the blue will really not come through. So after people have cataract surgery, they frequently report that the blues are unusually bright because many of these people haven't seen blue in a long time. So there's a little bit of blue in everything. So when I didn't see, I knew there were blue dots there because I've done this cataract thing. When I didn't see them, I wondered if I was cataracted. So I was so relieved to hear that Sarah was having trouble seeing them because they're all younger than me because she's 2 years closer than I am. So that was really good. Okay,
Sorry to scare
other
you.
stuff. Other stuff for, good, yes.
I like how you guys seem very knowledgeable, like you knew what you were talking about, it seems very well rehearsed, and you get to like continue to look at like your slides. You're so very knowledgeable.
A couple of other ideas. First, I wanted to just reinforce the earlier point. That was really well done. Nicely timed, nicely organized, sliding well like that. You seem to have an idea about where everybody was going with the slides. You're working well together. Very, very nicely done. Thank you for your preparation. A couple of times we talked about set size, and I know what that means. Occasionally you can remind us that set size is the same thing as the number of distractors. I know that you know that. And I think we use those terms interchangeably as well. You should have, but if you keep giving, especially early on, set size is the same thing as the number of distractors, because at some point we start seeing 4, 16, and 64, and people are aware that's the set size. They might not know that that's the distractor. And the signal to noise ratio is changing. You don't have to say it that way. You have always one signal, and either 4, 16, or 64. The noise is so you might say that. Yeah.
Just a question on that. For the image that we pulled up for the introductory slide, the set size was for the total of elements on the visual field together. Should I specify that this for that image is this, and then when Claudio speaks, should he specify that the 416 and 64 are our distractor numbers? Or set
You
them?
could. I don't think you have to put that by point on it. You're welcome to do that,
Okay.
but you don't have to.
Okay.
A couple of other things. So, log on factorial design, it's difficult to talk about our interactions and how we make sure that interactions are clearly communicated. And so what we might think about is this. We probably want to avoid saying something like we have the effective group and is group affecting set size, and set size affecting group. So we want to know if each of these variables is affecting the independent variable, which is the reaction time. So the independent variables don't affect each other. Right? So we'll be careful in how we talk about that. What we might say, and I got this little trick from Dr. Haskell, I love that he does this. He talks about, and he uses this gesture so you can all look at it, he talks about the combined effect of these two variables. He does that with the combined effect. So here's your group effect, here's your set size effect, and the combined effect of those two might be different than their individual effects. Right? So you might say something along those lines to help you get a very difficult idea of interaction. And it is a difficult idea. But I think that gesture can help with. So, and that's true for anybody. You can always think of your interactions as being the joint influence of these two independent variables on the dependent variable. Okay, I wonder if we also take a moment to go back to the graph. Very beautifully laid out there. Any one of them doesn't really matter. For this group and for all other groups, it would help the audience when you show a graph if you could be so kind as to walk us all the way through. Everybody in the room got quizzed on this graph. and on all of your graphs. But if you could kind of say, so on the y-axis, usually the point of the y-axis, we're plotting reaction time. On the x-axis, we have the number of distractors. I know that they can read that, but there's a tendency when you're very familiar with this to kind of go through the graph quickly, but your audience will be very naive to this. And can you also please tell your audience, after you've explained the y-axis and the x-axis, you also say, the different colors that we have here correspond to our other independent variables. And you don't have to say it more than once, but if you can give it to them one time each, it slows you down just a little bit so the audience can catch up to the factorial designs. So by deliberation, faculty have you do factorial designs as your culminating research experience. Even for the audience, this is a difficult thing to learn and to take in. But I know that you're all experts now on factorial designs. Your audience might not be with you, so if you can unpack all of that would be really, really good. Love the explanation, but I didn't know what to think about helicopter. I didn't know how to think about that. That was really cool that you have to keep the helicopter afloat. So you're being primed on making lots of responses. Very good, a good thought on that. One last thing that you might want to talk about, if I'm just eyeballing this was the target present case.
Yes.
Can we dial down just for a second to the target absence? Is there a big shift? Like, is one of these way longer than the other? Usually target absence is quite a bit longer. So you get up to something like, am I reading?
The reaction times are quite different.
Yes.
So we're going from 1 to 3,500 here, and on the other one,
It was 1 to 2,000.
2,000, right? And I realize we didn't analyze it that way, but does anybody in the room have an idea for why that's the case? Why is it that when the target is absent, it's way longer, by like a full second, maybe 1.5 seconds, than it is when the target is present? Is that intuitive to people? That, by the way, is a very reliable finding. So if your group didn't do anything wrong, this is something you always find. Why is that the case?
Can I answer? Okay. When the target is absent, especially if there are other targets of the same color as the target, or distractors of the same color as the target, people will take longer to go through and search each individual item to see if they can find
Right,
it.
so if you happen to see the target early on, that search is self-terminating, it just goes off. But if you haven't found it, you keep going and you keep going, and you say, okay, that's got something, then we'll go on to this.
Well, now that you bring that up, it may be beneficial to also have a slide of them that like side by side, so you can like absent, not absent, like the differences and like walk through and like explain that like while it's on or something.
Yeah.
And maybe if you have time.
Yeah, if you have time, if you're welcome to do that. It's an interesting point. It actually doesn't directly test your hypotheses and so forth, but it is interesting because that's a huge effect.
Right.
And your audience probably wouldn't know unless they're visual search experts. Cool. In the interest of time, can we just now thank Group 2 for a wonderful and we'll give you a moment to transition. I can do it this way. We can take a super short break. If you need to defuel or refuel, I don't need to do that. Well, 40 minutes off, we've got 40 minutes to go. So we'll see just one moment or two from groups 3 and 4. We've got 1 or 2 minute break, and then we'll come back into the groups 3 and 4. Boy, I would be the only else.
So many more.
Okay. But that is true. Maybe you have grandparents who have cataracts.
Yeah.
And they report that everything is fluid.
I turn on it.
Because they haven't been doing it in a long time.
Okay.
And they're,
Okay.
it's really cool.
All right, try it now. I don't know if that's supposed to be on your camera, but it's like giving you a message.
Yeah. That doesn't interfere with the grappling with it. So my iPad does like 12 things as I'm sure your iPad does. It also tells me that I have appointments in 2 days. I have to be at this meeting or that meeting. So that pops up. I see that all the time when I'm in message. You can't see it, but I can see it. All of a sudden, we'll be at, we start at 12:30, it's 1 o'clock, and I get a message saying, go to your meeting on Friday at 3. Unfortunately, that doesn't come out on the video. But thank you for the heads up, Jess. I appreciate that. Just another moment for.
Do you want me to click the slides when you talk? Or you can take the slides if that's helpful. No.
We can switch off. Click first. And
Okay.
I'll quickly.
Okay, sounds good. And then I'll project it.
Okay.
Actually, 15. Not everybody's that, but I also want to make sure that we keep on moving.
If you want to,
If
you
you're
want to have big
trying to
sale
ignore
on you?
the returning folks as they come in, we'll let the school go ahead and start themselves off. Log us in at 2:15 start.
So I'll say, I punch you.
Please go ahead.
Please.
Please begin right
Okay,
there.
and then I'll count. Everybody good? Okay. Hello, thank you all for coming. My name is Alex Hewlett.
I'm Liz Williams.
And I'm Jess Hess.
Today, we're here to talk to you about background color and ocularity with color acuity differences. So our statement of purpose, in following a trend in psychology, we crafted an experiment that looked at the validity of summation advantage of binocular ocularity in relation to varying luminances within a Farnsworth-Munsell 100-hue test, with the specific goal to see if there was any significance between the effects of ocularity, the effects of luminance, or an interaction between the two. Now, just so that you all know that I'm not pulling summation effect of ocularity out of nowhere, prior research that inspired us to do this was a study done by Gertman in 2013, which proposed the summation advantage of binocular ocularity within visual systems, or in relation to visual systems. So let me unpack that. That means a summation advantage is an advantage that exists in binocular vision that is probably caused by the summation of multiple visual pathways that exist within the brain. And as far as luminance goes, which is what we decided to manipulate in our test, we took inspiration from Elliott and Cow, another test done in 2013, in which we found that rods in our eyes mediated, at the very least, shortwave cones. This would be red or orange hues. And then for the Farnsworth experiment, we looked at many different color acuity tests, but the two big ones that came up were the Cambridge 13 and the Farnsworth 100. The Cambridge 13 test that we looked at was unable to find any summation advantages. However, we did find 2 prior Farnsworth-Munsell studies that supported the idea of summation advantage within the eye. So we looked at that, and we found evidence that the computerized version of the Farnsworth-Munsell was a good way of testing this and a valid way of doing so as well. So our research questions were how the total error score of the FM100 differed in relation to luminance background, we call it white or black in this scenario, error score given monocular or binocular vision, and how the two interact and affect error score as well.
So for the next part, we're going to talk about the method. So we used a 2x2 mixed design with the independent variables of background color, white versus black for within subject's variable, and ocularity, monocular versus binocular. For anyone who doesn't know, monocular means one eye and binocular means 2 eyes, and this was a between subjects variable. Our dependent variable was the total error score for the FM100 hue test, and lower scores indicate higher sensitivity. Therefore, basically, the goal is to score lower scores are better. And so our participants were 37 college-age students at Denison University. They were recruited via the SONA system from Psychology 100 classes, and they were given a compensation of 2 credits for 30 minutes of their time, and identifying characteristics such as gender, race, socioeconomic status, etc. were irrelevant and disregarded in this study. So for materials, we used one desktop computer per participant. There were about 10 per trial, but less at times because participants canceled. Additionally, we used one eye patch per participant for the monocular condition. We used the kind with like an elastic band, kind of like a pirate patch, that's the title of our study. And then another material was the Farnsworth-Munsell 100 hue test. And so this is what the test actually looks like. The first and last plate are set correctly and they're used as anchor points. So you can see it ranges from pale red to pale green in the first row. The next row goes pale green to teal, and then the next row is teal to indigo, and then indigo to pale red. Participants were to rearrange each row so the colors appeared to change gradually from left to right. And then, so our procedure was pretty simple. We first had participants fill out an informed consent form, and they were pre-assigned to either a white or black background. The white and black backgrounds were conducted at separate times, and we did 4 trials. And then participants sat down at computers where the test was set up. They completed the Farnsworth-Munsell 100 hue test twice. Half the individuals completed the test using monocular vision first, and then completed the test again with binocular vision. The other half used binocular vision and then monocular vision. After this, they were thanked and given a debriefing form. So our results, we actually had significant effects for the 3 main effects. So the significant main effect for background was significant. Oh, sorry, that didn't come out right. Okay. So the 2 main effects for both types of independent variables, background and ocularity, were significant, and then the interaction was also significant. And so this graph actually shows the means on the y-axis, and on the x-axis shows the 2 different groups of monocular and binocular. The blue is the black background, and the red is the white background. And by the differences in the bars, hopefully you can see the interaction effect.
So for the discussion, we have overall better color acuity when using 2 eyes. So this means your binocular system. So as Alex mentioned earlier with the previous research, there's a summation effect. So just that you have 2 visual pathways, and when you use both of them together, that'll give you a lower score on the Farnsworth-Munsell 100 hue test, and thus giving you better overall color acuity. The difference in color acuity for binocular vision is even more pronounced in the white. So whether you were in the white overall for binocular vision, that means that you had a higher color or a higher overall total score.
So that means that color acuity was worse in those conditions. And based on that, we can assume that black background is the absence of color, while white is the summation of all color frequencies. So maybe perhaps there was an interference between the frequencies on the white background. Both of these are supported by previous research, and then this just means that human physiology, there are two visual pathways working in tandem, as we said before, with the summation effect. And so as there are with a lot of studies, we have limitations. The lighting, we did not measure the lighting. We did 2 trials in this room and 2 trials upstairs in 515, I think it is. And the lighting could have been different, which could have projected different colors onto the screen or changed an individual's color acuity. Cognitive processes, such as attention or spatial processing, some individuals may have better cognitive processes than others, and we did not account for that, which could also have an effect on our results. The gamma correction of the screen, so if you go into a computer, you can correct the gamma correction within each individual screen, which we did not do, and that reflects in the saturation, hue, and color projection onto a screen. So therefore, like, that could have been different for each individual participant based on what screen they used. And then physical health deficits, whether you had cataracts, some sort of visual impairment, we did not account for that as well. So by nature, you could have better color acuity than someone else, and it might not have been just based on the background or ocularity. And then small sample size and population use may affect the generalization onto other populations outside of Denison college students. And then we did have an inconsistency in trial 1 compared to 2, 3, and 4. So in trial 1, we used like an adhesive eye patch, which is like a sticky eye patch that you use. And a lot of our participants were seeing like in discomfort, so it's kind of like a Band-Aid, so when they would just feel awkward. So we changed it for 2, 3, and 4 to have more like the Pyre eye patch with the elastic band. So since they were uncomfortable, that may have affected the trial 1 data. Yeah. And then so for future research, we advise using alternative independent variables such as gender. Are these results specific to male or female, as well as age? Do children or elderly individuals, would they show similar results, as well as background noise? If you project noise, does that interfere with cognitive processes, and would you get the same results? We discussed different background colors, so we used black and white. Would it be the same for pink and blue, or yellow and green, and just tons of possibilities there to continue testing and further understanding our findings. And then we chose to use the Farnsworth Munzel 100 Q test. And as Alex mentioned earlier, there are other color acuity tests out there, such as the Cambridge 13 test, and would those different tests produce the same results that we found? Yeah. So thank you for listening to us.
Okay, just to give you the timing, that was about 2 minutes long. So you're in range again. If you need to spend some more time or develop ideas more fully, that's okay, but you're roughly in range. Our students might have some questions and comments.
I
Gabby?
thought that all of you talked very clearly, and I appreciate that. I wish I could do that.
Oh, I appreciate your positivity.
I appreciated the clarity and discussion with you guys. It wasn't too much detail to get followed. But I had a hard time seeing some of the slides with these texts. So just make it out a little bit bigger.
Okay. Next.
I think one of the beginning slides, there are a few it seems a little messy, just cleaning that up, and then there's one slide that has a lot of text on it that you said out loud. So I think that abbreviating, kind of just summarizing that, and then letting yourself explain it is a lot better. But overall, the flow is really nice.
I just have a quick question. I might have missed it. On the slide with your graph, you saw on the y-axis, is that their score, the mean score?
Yeah, it's the mean score. I noticed when it was up there that we missed putting the label on. I think I just may have just copied wrong.
Yeah.
but
Yeah, it just might be.
think I said it. I don't know, but like it wasn't up there, so it like probably could have been more clear.
Okay, yeah, I would just
Yeah.
say if you can.
Yeah, because like when we talked about the other group with like making the graphs clear and stuff, that was you know, like I have to fix that when I talk in like 2 minutes. So.
Can you go back to that? Because that's not good. Yeah. So, yes, and it would help if several of you were talking about the score and the total score and so forth. It might help throughout the presentation when you can remember to refer to the score as the error score. Because when you call it an error score, then people will have an intuition that higher scores are going to be worse. Generally, higher scores in life mean better things, but not always. But so if you call it an error score, that might help. One other idea, since it does appear that maybe when you copy this one over, the y-axis can come through, maybe you'll go back. Just as a thought, you can always help your audience by making the colors on your columns relevant in some way. So you had a black background and you had a white background. You could choose to have this graph be grayish in its background, and then the column that represents the data from the black condition could be black on gray, and the one that represents the white background could be white on gray. Then it would be really obvious. So now it's something like red is white and blue is black.
Yeah.
So since you have to change that one anyway, you might be able to grab that one and just make it really, really obvious.
Okay.
A couple other ideas while we have just a moment. I would encourage this group, if you're so inclined, and the other groups, I think there was one other one, it's okay to use on your title slide, the opening slide, the fun title that we had. So this might have been something that was like a serious scientific title.
We can go with it out, we can keep it.
Because we might have some people in the room, if we can get some folks to join us, who want to hear about the pilot form, or want to hear about how we're going to use that to speak that. So please don't be afraid to use that on your opening slide. It really be just fine. If we can go back one or two slides, somewhere toward the early-ish part of the presentation, we had some really nice information about what ocularity is and the one article that was inspiring us on ocularity, and one article that was inspiring us on color. Yeah, if we could, it's fine that we have this. This might have been the ones that Madison was referring to. It's a little bit harder to see from back there. The font's a little bit small. But for me, the bigger idea is if we can change, however that name is pronounced, if we can change that to, if that's your ocularity effect, can you call that lead with ocularity? And then somewhere at the bottom you can put in that reference. So you don't have the reference. But people need to understand what ocularity is, and then you can understand what the background is versus what they will not remember, and probably shouldn't remember it as Elliot and Cal. So we can lead with the idea rather than leading with the activity. Okay. It would help if you wanted to. You could bring a pirate's patch or your eye patch, and you can show people what that's. You can hold it up. That might help. If you want to put in pictures of pirates along with cartoons, Wikimedia Commons probably have pictures of pirates. You're welcome to do that for fun. Just as an idea. A couple of other ideas. Oh, if you wanted to, because you're fine on time, you actually have a little bit of time to play with. You actually could call up online before you get on you dial up the FM 100 bit and show us what it looks like, and have us move one or two, or you can ask the audience to just pick a particular ship and say, should I move this left or right? And so some people have it's a fairly difficult task, right? It's also kind of a fun task. So if you want to spend a moment doing that, and say, you tell me which way this thing should move, left or right, given its current position, that might bring the audience in and give them some feel for what this task is. Something else from our students. Okay, well, another very nice presentation. Thank you. We thank them for it. Very well done. And we'll go on to group 4, and we've got 19 minutes. That's about right. That's about the right amount of time for group 4.
Stand right here.
You can hear me. Okay, I've got 2:32 as the start time, so that's fine. You're good to start anytime. See you. and loud.
All right. Hello, I'm Jake,
I'm Madison Ashbrook.
And I'm Gabby Vecchio.
and we are reporting on the relationship between blood glucose levels and reaction time in the Stroop test. And just to provide some general background information between the relationship of blood glucose levels and attention, prior research has shown that glucose administration has been shown to facilitate a wide range of psychological functions, and this goes beyond just attention. This also can be tied to memory. And performance increases on cognitive tasks. Performance has been shown to improve if participants consume a glucose-containing beverage before partaking in the task. But this relationship between blood glucose levels and attention is not directly based on blood glucose levels, but instead it's more based on the facilitation that blood glucose creates between acetylcholine synthesis and release. So when blood glucose levels are increased within the body, acetylcholine synthesis and the release of acetylcholine is also increased, which has been shown to have a direct connection to attention. Just for example, people with attentional disorders are very commonly prescribed cholinergic drugs in order to help them with their attentional disorders. And so specifically, we wanted to look at blood glucose levels and its effect on visual attention, which is why we chose to use the Stroop test. So our research question was, does the administration of glucose improve reaction times on both congruent and incongruent trials of the attention-based Stroop task? And our alternative hypothesis was that there should be a significant difference between the congruent and incongruent reaction times between the control and experimental conditions. So this is our current study.
All right, so we have a mixed 2x2 factorial design. We have 2 levels for the within subjects, which is the orange juice, or the beverage consumed, which is Tropicana Pure Premium Original Orange Juice with no pulp. And it has 22 grams of sugar in it, and that's a high glycemic drink. Oftentimes diabetics use orange juice to get a boost of glucose into their bloodstreams. And the control group drank crushed orange powder mixed with water, and it's like 5 calories and it has 0 grams of sugar. It's basically just orange flavored water, nothing really in it to produce any kind of increased glucose levels in the blood. And then our between subjects variable was congruency in the Stroop task. And so in the Stroop task, which we're going to talk about more, there are 2 things that it measures. Is one of them is congruent trials, which are color names that are written in, did I say? Incongruent is when color names are written in the conflicting colors, so like the word red written in green or the word blue written in red. And then a congruent trial is the color name that is written in the corresponding colors, such as green written in green and red written in red. And here's an example of that. An incongruent, usually it takes longer because it is something that is more attentionally demanding, so you have to think of the color green while you're looking at the word blue, and that's like an implicit memory is to say blue because you see it and it's a color, or it's a word you just know. You don't need to like read it or sound it out to know that it says blue, you just see it. So you have to like kind of use lots of cognitive process to say green instead of blue, whereas it's really easy to say blue in this one because you can see that, I don't know if you can see actually, it's kind of hard to see it, that it says blue and it's written in blue. And that's really easy to do, and people are usually very quick to respond to that on the Stroop task. Oops. All right, so we used CogLab 2.0, which is a software that is kind of vintage, and we plugged it into the computers, and the Stroop test is administered on that participants. So the words red, green, and blue are the stimuli, and they're presented on a colored screen approximately 50 centimeters in front of the subject, and each participant has their own computer. And CogLab records all the responses, which are the reaction times when you hit the keyboard, and you hit H for red, J for green, and K for blue. And it's all split into the categories on CogLab too, for congruent and incongruent. And then once you see the stimuli, you have time to react to it and press the key, and then it disappears immediately afterwards. And so reaction time is measured in milliseconds from the onset of the stimulus until you respond to it. And if a participant gets a trial wrong, it just goes away and comes back later, so that you always do the same amount of, everyone has the same amount of data in the end. All right, and here is our graph with orange being the orange juice people and blue being the flavored water people. And so in the experimental group, we see the congruent data is the one on the far left, and the incongruent data is on the right. And the control group has the two levels too. Wait, could you go back to the graph? So you can see that there's no significant interactions between any of them, or the main effects, because all the error bars tend to overlap. So we got no significance in that. We'll talk about why we think that happened. So here's our data with our sig value at 0.648, and our F value is pretty small also. So we must retain the null hypothesis that there was no difference between the orange juice group and the control group.
And don't mind my phone. Sorry, I can't really talk. But as with many designs and experiments, there's limitations and applications for future research. In our limitations, we discussed that we had no control over the dietary intake of the participants. We made note on SONA that we would appreciate that you didn't eat or drink anything an hour prior to coming in, but as always, you can't monitor your participants. We did not take an actual glucose level of our participants with a glucose meter to report the exact glucose, like in the bloodstream. And we'll talk further about that in our future research. We also discussed the possibility that in the orange drink that we administered, there wasn't enough sugar to make an effective difference. And this is referred to as power. We distributed 8 ounces, which is the serving size, with 22 grams of sugar in it. And like I said, we wish to provide enough sugar to make a difference. We also discussed that there is no initiation to the Stroop test, so this could prevent students or participants from performing at their best ability since they didn't have any practice time. Another concern was that participants could be primed or preconditioned to the Stroop test since our participants were all Psych 100 students. This is often introduced and used in psychology classes to explain the phenomena of visual attention and performance. And then for our future studies, we, as with many of the tests completed at universities, we would have liked a larger, more generalizable population, as well as a larger sample size for different results. And then higher control, regulation, and manipulation with glucose levels, as we talked about before, like possibly taking the blood glucose level so that we could decide if they could participate or not for that. And then for future research, we would also make the change to use a higher concentrated beverage with the sugar in it for the possibility of creating a more effective difference, and that possibly could be done through serving a bigger size or amount of liquid to the individual.
What's that?
Just said those were.
These are our references, and thank you for listening.
Okay, questions from our students or comments from the students?
I thought your guys' study was really interesting. Just like the other group,
even though you turn the lights down, it was still kind of hard to see. I don't know if there's anything you can do about it. I have no idea if you can like make the picture brighter or anything. But even when the lights were off, it was still like I couldn't read.
To see the
said
blue on the black.
Yeah, yeah, I couldn't read that it said blue. I mean, I could see like a blur, but that was. So I don't know if there's any way you can fix it.
Maybe I
If not,
could like make one. Like,
yeah, you might do like type it in there, but.
I really like that you guys had like, there wasn't too much information and you're like, not enough information, like, really, like everything out. But then if you like go back to your graph, like there's like labels at the bottom, I don't know, I can't read them, I don't know if you can make them bigger.
Oh, yeah.
Like, in, is what they.
Yeah, for incongruent.
Okay, yeah, if you guys like, I don't know if there's any way to make them bigger, but it's really hard to read those and then like the numbers on the side as well. Okay. So that's just like
Something else from our students? Any comments or questions?
One thing actually about the graph I was going to say is like you have any on it with, I kind of had to think for a second of what those meant. So maybe you could write this out.
I think we put it down here in this paragraph, incongruence. It's just that they're longer words, and I don't know if they would like, might have to like, you know what I mean, like fit on that.
It just seems a little informal.
Yeah.
Like the shorthand.
Okay.
That's just something. And then another thing I noted was that he was really well pleased and like the slides were pretty well like not over wordy it seemed like, but then when you got to I think like when you were talking about the Stroop test, it was like paragraph forms, and I think it would be more beneficial to like have it like bulleted or just to make it broken up.
Anything else from our students? Other comments or questions, suggestions?
I have a question, like generally for all the presentations, when we present on Wednesday, do we have to like explain what Cog Lab is if they don't know?
You can just say we use CogLab software. That's
Okay.
fine. All right. So a couple of comments. First, very nicely done. I clocked it in at about 9 minutes. That one was a bit shorter than the 12-minute mark that we're shooting for. So if you wanted to develop other ideas a little bit more fully, that's fine. So you're 89, you're not too far out of range, but you're running a little bit on the short side. It's perfectly fine for you to use the fun title if you want. It's a great title that you had at Getting Juiced on the Street. Right? So that may or may not have been on your first line, but you're welcome to use that if you're so inclined. Love the conversation or the discussion about acetylcholine and attention. Really, really great stuff. A very nice tie, especially when you come back to cholinergic drugs being prescribed for attention. It's very, very relevant. I'm grateful to Sarah again for saying that I couldn't see the word blue there, and I wondered, okay, when lights go down, thank you, Becky, for turning lights down. I still couldn't quite get it. So it might help if you do just, and I realize that's not your fault. That's just, you probably took that right out of CogLab. And CogLab's blue turns out to be really, really light after it goes through copying and projection onto this screen. So, one of the nice things about having practice runs, you get to see what's clear, because we're going to be in this room in the same kinds of lighting conditions. Can you go back to the coherency graph? So I thank you. Somebody over there was saying, might suggest that the print is a little bit small. So thank you there. I was wondering if my eyes were going again, but that might be a bit bigger. Something else I noticed is that normally what happens is you take one of the conditions in your group, one of the levels of your group variable, and you put them on the left, that's the experimental condition, and you put the control group on the right, that's fine. So you have a left versus right spread. Okay? But then we typically take the colors and we recolor them, so now it looks like really the experimental group is orange, and the control group is blue. But usually what we do is we make, for example, the congruent color orange, and the incongruent color blue, or something like that. So it would go orange, blue, orange, blue. Okay. Does that make sense?
Yeah, I was trying to do something to like differentiate that, but I couldn't like make these closer. I don't know how to do that, so I thought it would be easier to separate it that way.
Okay, so we typically have one cluster that's the experimental cluster, another cluster that's the control cluster, and then within a cluster we have the two different colors. So right now, it's really, really clear what's experimental, what's control.
Yeah.
And I think I'm seeing that orange is, the colors are not differentiating that other dimension variable.
So this one should be orange and this one should be blue.
Yeah, any way that you want to lay that out. If you want to have the colors help your audience understand that other dimension variable, that is what might be helpful. Okay, one other thing. So this is the control group on the right-hand side. This is the group that got substantially less sugar. Am I seeing correctly that they are actually slightly faster? I know the effect is non-significant.
Yeah,
Not
the-
only was it non-significant, it's actually, what I understand to be perhaps the wrong direction. Is that, or am I wrong about that?
I mean, the error bars for the congruent on both of them are overlapping, so it's not really,
Okay.
like, it looks like it was faster. But
The after times are slightly longer for the left pair than they are for the right pair.
yeah.
Now, and yet the left pair is the group that got the sugar.
It's almost like a rectangular distribution now, because they're all pretty much overlapping with each other.
I'm also intrigued that Conrad didn't deliver, okay, we'll do it that, you've got your, so almost a backwards, I realized it wasn't significant, but it is intriguing that we didn't even get a trend going. You may have said, I'm not remembering, how long do people have to wait after they have taken in the, did they watch the video, right? Did you watch the video?
Yeah, it was 17 minutes.
Okay. Okay, other comments for this group? All right, why don't we thank group 4 for letting us listen? And thank you all, we're at 2:48, so we did it with 2 minutes to spare, and that's a good time management and a good preparation. I look forward to being together on Wednesday, and that'll be our final session. Thanks, everybody.